Today's topic is minimization of DFA. Minimization of DFA implies converting a given DFA to its equivalent DFA with minimum number of states. So a DFA may have many states and all states may not be required to accept the language. So here we'll do the minimization of DFA. Now suppose we have an original DFA, that is Q, sigma, Q naught, delta and F. It is defined using this tuple. And this DFA recognizes language capital L. Now our task is to minimize this DFA to this DFA. Now minimize DFA is having these 5 tuples: Q prime, sigma, Q naught, delta prime and F naught. Idea is that the both DFAs, original DFA and minimized DFA, should accept the same language. Mean they should be equivalent in terms of their language accepting capability. Now this conversion can be done using these 3 steps. They are very simple steps. Now first step is to obtain S0. S0 stands for 0th equivalent class. So in this conversion we will be obtaining equivalent classes. Now first equivalent class is S0, that is 0th equivalent class, and S0 is equivalent to a set, a pair of sets rather. So it is Q1 naught and Q2 naught. Now Q2 naught is a set of all final states and Q1 naught is set of all non-final states. Now suppose here we have DFA that has states Q and here final state is F. So this is a set of all final states. So in Q2 naught will have all final states and in Q1 naught will have all remaining states, mean all non-final states. So in that way this 0th equivalent class will be obtained. 0th equivalent class mean without reading any input symbol, these states are equivalent in nature. So S0 mean a set of all final states and here we will have set of all non-final states. So this pair is called as S0. Now in step 2 we'll construct Sk plus 1 using Sk. So this is a successive step and it will be obtained using the previous equivalent class. So how to obtain? There are 2 simple conditions. First we'll take any 2 states Q1 or Q2 from Qik. So Q1 and Q2 should be from same equivalent class. Now these 2 states will be in K plus 1 set also. The condition is we'll obtain delta of Q1A and delta of Q2A for all A in sigma. So we'll obtain delta of Q1A and delta of Q2A. The resultant states, if they are kth equivalent, then we'll say that Q1 and Q2 belongs to Qj K plus 1. And we'll repeat this step 2 until Sk is equal to Sk plus 1. This step will be more clear in this example. So now we'll take one example. Now in this example there are 5 states: Q0, Q1, Q2, Q3 and Q4. So states are Q0, Q1, Q2, Q3 and Q4. Transitions are marked in this diagram. This is DFA and here final state is Q4, alphabet is 0, 1 and start state is Q0. So for this given DFA, we can easily plot this transition table. So in this transition table, this is present state and here we can mark the next states. So at Q0 for input symbol 0, next state is Q1. So here we can write Q1. At Q0 for input symbol 1, next state is Q3. So we can write here Q3. At Q1 for input symbol 0, next state is Q2. So here we can write Q2. At Q1 for input symbol 1, next state is Q4. So we can write here Q4. At Q2 for input symbol 0, next state is Q1. So here we will write Q1. At Q2 for input symbol 1, next state at Q2 for input symbol 1, next state is Q4. So here we can write Q4. At Q3 for input symbol 0, next state is Q2. At Q3 for input symbol 1, next state is Q4. At the state Q4 for input symbol 0 and 1, next state is Q4. So in that way we can complete this transition table. Now our task is to minimize this DFA. So we'll apply step 1. In step 1 we'll obtain 0th equivalent class. So here we will obtain S0. S0 stands for 0th equivalent class. So basically it will obtain a pair, and this pair we will have two sets. We can write two sets like this. So in first set we'll write all non-final states. So states are Q0, Q1, Q2, Q3, Q4, and Q4 is final state. So remaining non-final states are Q0, Q1, Q2 and Q3. So in first set we will write Q0, Q1, Q2 and Q3. Now in another set we will write the final state, that is Q4. So in that way we'll obtain 0th equivalent class, set of all non-final state and set of all final states. So in that way we'll obtain. Now next is step 2. Step 2 mean to obtain k plus 1. So here we will obtain S1. S1 will be obtained with the help of previous equivalent class. So we will obtain S1 with the help of S0. So here we will check whether all these states are 1 equivalent or not. Q0, Q1, Q2, Q3, they are 0 equivalent. Q4 is 0 equivalent. This is a singleton set only, and they all are 1 equivalent. Now we need 0 equivalent. Sorry, they all are 0 equivalent. Now we need to check, are they 1 equivalent or not. So for doing this, we'll apply these steps. Now we'll take two states and two pair of states from this set. Now suppose we are taking a state that is the Q0 and Q1. Q0 and Q0. Q0 and Q1. In this set, these all states are 0 equivalent to each other. Now we need to check its 1 equivalency. So two states randomly we had taken Q0 and Q1. Now we'll obtain delta of Q0 for input symbol 0 and delta of Q1 for input symbol 0. And then we'll write here the next state. At state Q0 for input symbol 0, next state is Q1. At state Q1 for input symbol 0, next state is Q2. This is okay. Similarly, we'll obtain the transition for another input element, that is 1. So at Q0 for input symbol 1 and delta of Q1 for input symbol 1. Again we will obtain next state at Q0 for input symbol 1. Next state is Q3. At Q1 for input symbol 1, next state is Q4. Now we'll check whether these are k or 0th equivalent or not. So 0th equivalent mean Q1 and Q2. For 0th equivalent, Q1 and Q2 should lie in same set. So here we'll check Q1 and Q2. Q1 and Q2, they are lying in same set. Now check for next input symbol, that is 1. For input symbol 1, next states are Q3 and Q4. Q3 is lying in this set while Q4 is lying in this set. So we can say that Q0 and Q1 are not 1 equivalent. So we need to split this original set or this 1 equivalent set. So here Q0 and Q1 cannot be placed in one set. Rather, they will be splitted out. So they will be kept like this. This is rough step that we are doing. So Q1, Q0 and Q1 are not 1 equivalent. So here splitting has to be done. Now we'll repeat this process for all pair of states. So now we'll take another pair like suppose Q0 and Q2. So states now Q0 and Q2. We'll check are they 1 equivalent or not. They are 0 equivalent, but are they 1 equivalent or not. So we'll obtain next state Q0 0, delta of Q2 comma 0. For so Q0 0, at state Q0 for input symbol 0, next state is Q1. At state Q2 for input symbol 0, next state is Q1. Alright. Now we'll do this for all input symbols. Here we have only 2 input symbols. So again we'll obtain next state for another input symbol. So Q0, comma 1 and delta of Q2, comma 1. Now Q0 at state Q0 for input symbol 1, next state is Q3, and at Q2 for input symbol 1, next state is Q4. Now we'll check the equivalency here. Now for input symbol 0, next states are Q1 and Q1. Q1 and Q1 definitely will lie in one set. Now for input symbol 1, next states are Q3 and Q4. Q3 is lying in this set and Q4 is lying in this set. So we can say that Q2 and Q0 and Q2 are not one equivalent. Now we'll try to check the equivalency of Q1 and Q2. So delta of Q1, comma 0 and delta of Q2, comma 0. Similarly, we will obtain delta Q1, comma 1 and delta Q2, comma 1. Alright. Now at Q0 for input symbol 0, next state is Q2. At Q2 for input symbol 0, next is Q1. Now at Q1 for input symbol 1, next state is Q4. At Q2 for input symbol 1, next state is Q4. So now we'll see the next states for input symbol 0. Next states are Q2 and Q1. Q2 and Q1, they are lying in same set. Now here next state are same Q4, obviously they will lie in one set. So here we can say that Q1 and Q2 are one equivalent. So Q1 and Q2 can be kept in one set like this. Now we'll check the equivalency of Q3 with these states. Q3 with these states. So first we'll check the equivalency of Q3 with Q0. So just check here Q0 and Q3, these two states, Q0 and Q3. Now Q0 for input symbol 0 goes to Q1 and Q3 goes to Q2. Q1 and Q2. Q1 and Q2 are lying in same set. Now check the same for input symbol 1. For input symbol 1, at Q0 for input symbol 1, next state is Q3, and at Q3 for input symbol 1, next state is Q4. Q3 and Q4. Q3 lies in this set while Q4 lies in this set. So Q0 and Q3, they are not one equivalent. They are not one equivalent. So Q3 cannot be kept in this set. Right? Now we'll check the equivalency of Q3 with these states, another states like Q3 with Q1 or Q2. So first we'll check the equivalency of Q3 with Q1, Q3 with Q1, Q3 and Q1, right? So at Q3 for input symbol 0, next state is Q2. At Q3 for input symbol 0, next state is Q2. Q2 and Q2, they are lying in same set. Now at Q1 for input symbol 1, next state is Q4. At Q3 for input symbol 1, next state is Q4. Q4 and Q4, same state they are there, obviously they will lie in one set. So here we can say that Q1 and Q3 are one equivalent. Q1 and Q3 can be kept in one class, one set. So Q3 will be written here. Now see here, we know that Q1 and Q2, these two states are one equivalent. Q0 and Q3, they are also one equivalent. So obviously Q1 and Q3 will be one equivalent. So in short we can say Q1, Q2 and Q3, they all are one equivalent. Q1, Q2 and Q3, they all are one equivalent. So in that way we did the splitting of set. These states are zero equivalent and these states may not be one equivalent. For checking it one equivalence, we obtain first equivalent class. In first equivalent class, we applied these steps wherein we check the next states for all input symbol A and next state should be K equivalent. Kth equivalent mean next state should lie in same set, either in this set or in this set. Now we'll repeat step 2 until Sk is equal to Sk plus 1. So here we will obtain S2. We'll obtain S2 with the help of S1. So here again we'll obtain the pair. The first set is having only one element, so no further splitting is possible. Now in second set there are three states, Q1, Q2 and Q3. We need to check are they two equivalent or not. So we'll apply the same process. So we'll take any two states. Suppose we are taking Q1 and Q2. Q1 and Q2. So Q1 and Q2. We have already obtained it, rather we'll see here Q1 and Q2. At Q1 for input symbol 0, next state is Q2. At Q2 for input symbol 0, next state is Q1. Q2 and Q1. Q2 and Q1 are lying in same set. Remember, while obtaining S2, we'll look the sets given in previous equivalent class, not in this or previous, just in previous equivalent class. So next states are Q2 and Q1 and they are lying in same set. Now again check the equivalency of Q1 and Q2 for input symbol 1. For input symbol 1, next states are Q4 and Q4, and Q4 and Q4 this is lying in same one set. So here we can say that Q1 and Q2 are two equivalent also. Right? Now we'll check the equivalency of Q3 with any of these two states. Suppose we are checking the equivalency of Q3 with Q3 and Q2. So Q3 and Q2. Q3 at Q2 and Q3 for input symbol 0, next states are Q1 and Q2. Q1 and Q2 lying in same set. And for input symbol 1, next states are Q4 and this is lying in same set. It means we can say that Q3 is 2 equivalent to Q2. So Q1, Q2, Q3 can be kept in one set. Now Q4 is singleton set, so no further splitting is possible. So in that way we have obtained S2. Now here just see that we have obtained here S1 is equal to S2. So here we will stop the process because no further splitting has been done while obtaining S2. So here we can say that here in second equivalent class we have three sets. Now these three sets will give us the notion for states in minimized DFA. Now first set is this, second set is this, and third set is this. Now we can give name to this set like A, B and C. For more clarity, I'll give name to this set as Q0. Or here this set has members Q1, Q2, Q3. So I'll give the name to this set as like this, I'll use a square bracket. In a square bracket I'll write the states Q1, Q2 and Q3. Similarly, I can give name to this set as Q4. This is just the notation, and what this notation is depicting. So this notation is showing that this particular state, this is name of the state only, this particular state comprised of Q3 states, Q1, Q2 and Q3 of original DFA. Now actually this state and this state and this state, these will be the states of minimized DFA. So we can say in minimized DFA, suppose one state is this one, and this state of minimized DFA is comprised of three states, Q1, Q2 or Q3 of original DFA. So after seeing the state name only, we can easily answer that what is the composition of these states, how they are composed of. Now next is, we will try to draw the transition table for minimized DFA. So here we will write the states. Suppose the states are Q0 and here Q1, Q2 and Q3 and Q4. So we are drawing this transition table for minimized DFA. So in minimized DFA, again input symbol will be 0 and 1. So states are Q0 and this and this. So now we'll see the transition table for original DFA and we'll plot the table for minimized DFA using this table. So at Q0 for input symbol 0, next state is Q1. Next state is Q1. Q1 is lying in this set and name corresponding to this set is this one. So here we will write Q1, Q2, Q3. This is a state is minimized DFA corresponding to this state Q1. Now at Q0 for input symbol 1, next state is Q3. Q3 is lying in this set and name corresponding to this set is this state. So here we will write Q1, Q2, Q3. We already know that Q1, Q2, Q3 are equivalent states. Now we'll see Q1, Q2 and Q3 mean Q1, Q2, Q3. For input symbol 0, next states are Q1 and Q2. For Q1 or Q2, they are lying in this set and name corresponding to this set is this one. So here we will write Q1, Q2 and Q3. Now again for this set of states, group of states, next states are Q4 and Q4 is lying in this set, name corresponding to this set is Q4. So here we will write Q4. Now at state Q4 for input symbol 0, next state is Q4. So here we will write state for minimized DFA. Q4 for input symbol 1, next state is Q4. So here we will write state in minimized. So this is our transition table for minimized DFA. The minimized DFA has these three states. Now using this transition table, we can plot the transition diagram. So transition diagram, here we have the states like this. Name to the states is Q0, here Q1, Q2 and Q3, and this is Q4. Now we need to find what will be start state and what should be the final state. Now in this particular set we can say see Q0. Q0 is a start state of original DFA. So start state for minimized DFA will be this state. Now final state in this DFA is Q4 and Q4 is lying in this set. So final state for minimized DFA will be this state. So we can mark here the start state is this and final state is this. Now we can mark the transitions at state Q0 for input symbol 0, next state is this. Now at state Q0 for input symbol 1 also, next state is this. At this state for input symbol 0, next state is same. So self loop will be marked for symbol 0. At state this for input symbol 1, next state is Q4. So transition will be marked like this. Now at Q4 for input symbol 0 and 1, next states are again Q4. So self loop will be marked like this. So we can see that original DFA was having 5 states Q0, Q1, Q2, Q3 and Q4, while our minimized DFA is having only 3 states. Its transition table is given here and its transition diagram can be plotted very easily. Now one more remark is there that if there is any inaccessible state from start state, then that state should be removed before applying this minimization process. So this all completes the minimization process. Thank you.